Hi everybody. This brings us to the last section in chapter 9. Even though it is at the end of the chapter, it's probably the culmination of everything we've done mostly in this chapter, so it's a pretty important chapter. It's called Solving Rational Equations and Inequalities. The hardest part of this, I suppose, is coming up with that common denominator. In order for us to solve this, wouldn't it be nice if we could get all of these denominators to be the same? Because if they're all the same, then the numerators would have to be equal to each other. And so what we're going to do is we're going to say, well, let's find out what the common denominator would be. Multiply top and bottom by those, and then we'll know what to do. Now, I'm going to leave myself a little room here. And the reason I do that is because if I'm going to solve this equation right in place here without having to copy everything over, I want a little bit of room right here. Now, as I look at the denominator, I notice that there's a 28 here. This one doesn't have 28, so it needs 28 top and bottom. This one has a 4, so it really needs a 7 top and bottom. Now I've got 28 down here. All of them have 28. And none of these, except for the one in the middle, these two don't have z plus 2. So we don't need to multiply this one times anything else, but this one we need to multiply times z plus 2. And I'm doing it top and bottom to keep the equivalent fraction here. Now I've got 28 times z plus 2, 28 times z plus 2, 28 times z plus 2. Notice I'm putting them in parentheses here so that they get their due justice. There's 28 times z plus 2. All of them have the same denominator. Once again, you got to multiply top and bottom by the same thing to stop from changing the original problem. Now, if all the denominators are the same, then the numerators would have to be the same. Well, let's prove that to be true. Let's say we have a fraction x plus 2 over 5, and this has a 5 on the bottom, and this is 3. Well, the only way that this could work is if the numerators were equal to each other, right? So it's the same thing here. We're now, at this point, going to disregard the denominator. They end up canceling away, and I don't need to write them again. So I'm trying to keep my work down to a minimum here. So on the top, we got to distribute here. I got 9z plus 18. Plus, and we'll talk about that plus sign in a minute, 28 times 3, well, that's 84, I believe, yes. And over here, I've got 21 times z plus 21 times 2, or 42. Now, this particular problem we're starting with here has all plus signs, just so they don't get in our way for the moment. We'll do a couple problems with subtraction signs in there, and we'll have to be cautious of what we do when we're distributing. 3 times 7 is 21, and that 21 times z, and 21 times 2. So there you go. Now we just solve this linear equation. I'm just going to solve it the way I normally would, subtracting 9z from both sides. This here is 102, and this is 12z plus 42, subtracting 42 from both sides. We get 60 equals 12z, or z, and then divide by 12, and I'm out of room here, but z is equal to 5. Now there's my answer. But if you recall way back at the beginning of this chapter, when we solve these problems and we come up with answers, we have to check those answers back in the original problem. And if I put 5 in for z up here, will I ever get a denominator that's 0? Well, 5 goes in here, makes it 7. That's okay. So this answer is okay. We check that answer off. You've got to check these back in the original problem, particularly in the denominators in this chapter. Let's take a look at one with some subtraction signs. Before we deal with one that has subtraction signs, let's take a look at one where some factoring might be involved here. As I look at this problem here, I notice that this can be factored on the bottom here, r squared minus 1, and I think this one on the top can be factored. So I'm going to rewrite the problem. This is not the difference of squares here, so I'm not going to try factoring it. But this is the difference of squares, r plus 1 times r minus 1. And on the top here, I have, let's see, r plus 2 and r plus 1 all over r plus 1. Okay. You know, I already see here where I can do something to simplify my work possibly, but actually that's going to kind of work against me if I do that. I could cancel these, but I'm going to have a common denominator of this anyway. So I've already got that denominator, so I'm not going to cancel here. But to get a common denominator, this one has both r plus 1 and r minus 1. This one has r plus 1. So this one over here needs an r minus 1. I'm leaving myself some room to put it in there. Okay? And now the denominators are the same, r plus 1 times r minus 1. So we can set the numerators equal to one another. I know that r plus 1 times r minus 1 happens to give us r squared minus 1. So I'm just going to write it that way. These two here give me this, okay? Now, if I'm going to solve this, I'm going to need to get I'm going to need to I'm going to have to expand this, I believe. Let's see what happens if we expand this by foiling. R times r squared is r third. R times negative 1 is negative r. 2 times r squared is 2r squared, and 2 times a negative 1 is negative 2. Okay, well, let's set this equal to 0 and see what happens here. If I set this equal to 0, move some stuff around a little bit here. If I set this equal to 0, I'll get r cubed. Subtracting r squared from both sides, I get r squared here. I'm sorry, positive r squared. I've got a negative r, and I'm going to add 5 to both sides. I get plus 3. Now, you could probably put this in your calculator. We're not going to take the time to solve this, but you could put this in your calculator and see what the solution would be. But I'm not going to finish this particular problem. But just to point out that sometimes it helps to factor things to see what to do. Let's try a different one. All right, this is the kind of problem that comes up it's pretty common to have a problem like this. My common denominator here is going to have to be t. This is over 1 and this is over 1. And I can see that if I multiply everything by t, I'll have a common denominator here on the bottom, by t on the top and bottom. Let me show you another technique that we can use rather than just changing each fraction one at a time. Since I know the common denominator is t, if I multiply both sides by t, see what happens here. Distributing in, t times t is t squared. Distributing in, t's on the bottom and top right here are going to cancel, and I just get 12. And t times negative 8 is a negative 8t. 0 times t is still 0. Okay? Now let's rearrange these. And I recognize that this possibly can factor. So let's factor it. Let's see. T minus 4 and t minus 2, minus 3. No, that doesn't work. Oh, how about 6 and 2? Yeah, that works, 6 and 2. T minus 6 and t minus 2. There's negative 8t and 12. So if I solve this using quadratics here, t minus 6 is equal to 0. Set each one of these equal to 0 and solve it. T is 6 and t is 2. Now those are the answers that we've got here. If an answer didn't work, we'd call it extraneous. If it doesn't work, it's an extraneous solution. Extra We found it, but it doesn't work in the original. But let's see if any of these are extraneous solutions. If I put 6 back in here, in the denominator particularly, that's okay. And if I put 2 back in here in the denominator, that's okay. So both of these are good answers. There's no extraneous solution in this particular problem. Okay? All right. Part of this assignment is going to be to do inequalities. And this is where things get a little bit more interesting and have a little bit of extra work at the end that we're going to need to do. If I try to get a common denominator here, it looks to me like the denominator has to be 8 times a. Now, if the denominator is 8 times a, I'm going to use the technique I used in the last problem, and I'm going to multiply both sides by the common denominator, 8a. And the stuff's going to cancel away. This was a technique that was very important for us to learn at the beginning of the year here. I'm going to distribute in. Here I go. 8a over 4a is 2 times 1. 8a over 8a goes out. 8a over 8a goes out, plus the 5 there, times 1 times 5 is 5. And over here, 8a over 2 is 4a. 2 cancels with 8 and makes 4a. So if we distribute this in properly, the 8a's canceled here. 8a and 4a reduced to 2. And I end up with 7 is greater than 4a. Finally, if we divide both sides by 4, a is less than 7/4. Now, there's something that we should have been doing at the beginning of this problem. If you recall from the beginning of the year, or the beginning of this chapter, we talked about the domain restriction. Well, what can a not be? Well, in the denominator here, a cannot be 0. If a is 0, that's 0 in the denominator. A is 0, that denominator is 0. So we see that a cannot be equal to 0. Okay? Well, we're going to use that number, and we're going to use this number, and we're going to need to make a little graph. Seems like a little extra work, but that's what it is. And I'm going to find those spots, both of them, on my graph here. Let's say that 0 is here. 7/4 is about 1 3/4. Let's put it here. And I'm going to kind of make a little dotted line here. I have 3 regions I have to check. According to this, a has got to be less than 7/4. Let me turn that around so we can see it the other way. A is less than 7/4. That would be down here. So I'm suspecting that this section here probably works. So let's go back up in the original problem and let's put in, say, 1. Let's put 1 in here. 1 over 4 times 1 is 1/4. Make a little jot over here on the side. Plus 5 over 8 times 1 is 5/8. 1/4 plus 5/8. Well, what is that? That's 2/4, or 2/8 and 5/8 is 7/8. Is 7/8 greater than a half? Question mark. Yeah, it is. So this section is part of the answer. It is, yes, it is less than 7/4. If we try to number up here, say 2, let's put 2 in there and actually do the calculations again. I'm suspecting this won't work up here. This will not work. Let's find out, okay? 1 over 4 times 2 is 8, 1/8. Plus 5 over 16, 5/16. Well, 1/8 is 2/16. 2/16 plus 5/16. Is that greater than a half? Well, 7/16 is not greater than a half. So this doesn't work over here, which I suspected. Okay? So this is not going to include 7/4 because it's not equal to. So we know we're down here. The real question now is, what about down here? What if I put a number down here in this third section? It's not just enough to go forever. Let's see what happens. Let's pick a simple number down here, say a -1. Okay? -1. Let's put it back in the original. 4 times a -1 is a -4. 1 over -4 is a -1/4. Put a -1 in the other part of it here. Negative 1 times 8 is a negative 8. That's a negative 5/8. Altogether, that's negative 2/8. This is a negative 7/8. Is that greater than a half? Negative 7/8? No, of course not. So this section is no as well. So that means our answer has to be sandwiched between these two. It can't be 0. We just said that here. So our answer is going to be A is sandwiched between 7/4 and 0. There's your final answer. And as you try these problems, you're going to need to check these regions. It's done in your book for you. The same problem is done in there if you need to come back and take a look at it. You're checking to see if those three regions. Now, inequalities, you can't just assume it's going to go on forever. You have to take that domain restriction and use it as one of your boundaries and see if it works beyond that boundary. All right, let's take a look at this one. And this one has a kind of a special situation that you might come up against every once in a while, just to kind of alert you to it. One of the problems that we have when there's a subtraction sign in a fractional problem is people tend to forget that subtraction sign gets distributed in the top. And that may be something we need to deal with. To avoid that potential problem, we know that subtracting this fraction is the same as adding the opposite. So I'm going to change this to a plus sign and put the negative sign in the top so I don't forget about it, that it's there. If I don't do that, I may end up not forgetting to distribute properly. All right, so that's the first thing you want to do is try to get rid of any subtraction signs by adding the opposite, adding a negative there. Now, as I look at this problem, I see that this one on the bottom factors, and this one I might be able to turn around. So let's see what happens here. Let's bring this one down. And let's factor this one on the end out here. Y squared minus 4 is y plus 2. It's the difference of squares. And y minus 2. And this one in the middle is actually the opposite of this one. Y minus 2, 2 minus y. If I multiplied top and bottom by negative 1 here, I'll end up with a problem that's going to be easier to work with. Let's bring all of this down. Multiplied top and bottom by a negative 1. I now end up with a positive y on the top. That's good news. And on the bottom, I end up with a negative 2 and a positive y, or y minus 2. All right. Now, let's check to see what the common denominator. There's a little bit of work we could do before we actually start looking at the denominator. If you recall, we're looking for the highest power of each factor, but use it only once. Well, there's y minus 2. It's in this one, but it's not in this one. So I'm going to multiply this one times y minus 2 top and bottom. And there's y plus 2. It's in this one, but not in this one. Well, I'm kind of out of room here, so I'm going to squeeze it in here a little bit. I'm going to multiply this one by y plus 2 top and bottom. And by doing that, all of these factors now, all of these denominators are the same. And it's at this point that you would go ahead and just, at this point, since the denominators are equal, we can ignore the denominator and just check the numerators at this point. Let's distribute here. 2 times y is 2y minus 4. Plus, let's distribute here. Y squared plus 2y. And here we have y squared plus 4. The denominators are all the same. So when I add together these numbers, the denominators are all the same. It's just the numerator that we need to check. Now at this point, we just go ahead and solve for y. I see here that y squared, if I subtract a y squared from both sides, those are going to go out. So I'm going to have 4y minus 4 equals 4. And adding 4 to both sides, I get 8. So y has to be 2. All right, so we found out that our answer, y has to be 2. Well, y, if I put it back up in here, that's okay. But if I put 2 in here, that makes this denominator 0. So this number cannot work in our answer. Turns out it doesn't work over here either. Y squared would be 2 squared is 4 minus 4. It only doesn't need to work in one place for it to be allowed. This is an extraneous solution. We get it for an answer, but it's not allowed. So this is an answer you wouldn't put down unless they asked you for the extraneous answers. So we got one answer here, but it didn't work. And this particular problem happens every once in a while. Well, you find that an answer will not work in the original problem. All right, to summarize, what are you going to be looking for here? Well, first of all, you want to check all problems at the end. Make sure you check them to see if a denominator becomes 0. See if any denominator becomes 0. Check all problems at the end, okay? Number 2, your goal is to try to get a common denominator, get lowest common denominator, and if possible, once they're all the denominators are same, you can ignore the denominators. Ignore the denominators and solve the numerator. Solve the numerator only. Okay? Don't forget to check those problems at the end. Coming up with that least common denominator, lowest common multiple, is usually the hardest part. You'll notice in the book they just multiplied everything by the lowest common denominator like I did one time. You could do it either way, just change each fraction or multiply by the lowest common denominator. They give you those steps on page 508. And finally, with inequalities, you must show a graph. For example, a linear graph, and whatever those excluded values are, or excuse me, the answer is going to be one of them possibly, and the other one is probably your domain restriction. And if there's a domain restriction here, that's another boundary. You check those boundaries out to see which one would work. This one worked here, did not work over here. Pick a number in the middle there somewhere, any number that's easy to work with. Here I picked 1, here I picked 2, here I picked -1. Just pick a number, in any number you want, that will make it easy to stick it back in the original problem. And you'll be able to determine which ones worked. Here, just the ones in the middle worked, so our answer would just be these in the middle here. So here's your homework for tonight. All right, I'm going to put up both assignments here. You have enough to get you through this first section here. All the odd ones, you can check those in the back. I'm going to put up the next assignment up here as well. There are some story problems, and I'm going to record another video tomorrow. Just kind of deal with some of those story problems if you're having some difficulty setting them up. I particularly want to take a look at problem number 10. It's critical, so don't miss that video tomorrow. Number 10 is important. It's an important problem. You'll see that on SAT tests. If you're not sure how to do it, tune in for the next video. All right, we'll talk to you later.